the rational function 4.1. We are not going to finish this one, it's a very big section. So 4.1 is I talk about the domain of the rational function and the asymptote, but we didn't finish it. So we give you example on this one first, and we go over the practice quiz, okay? So this is it, example that we're going to have. We want to find the domain, okay, the domain and all possible, okay, possible asymptotes of each rational function, rational function. It's going to be kind of 4 different types, and I explain all of them. And we give you just a couple of questions on this one, or just one. Okay, there you are. The first one. First one is going to be easy one. Okay, the first one is f of x. F of x is equal to the 5x minus 1 over x plus 2. That's a rational function. You see the top and the bottom are polynomials. We talk about it. The domain of these functions, remember, since it's a fraction, denominator cannot be 0. So you let denominator equal to the 0 to find, because the x is free, but x cannot take a value that make denominator equal to the 0. So solution, domain first, you see the domain. Domain is going to be, this is it, denominator equal to the 0, x plus 2 equal to the 0. That gives you x equal to the negative 2. So everything except negative 2. Remember we did before? So you pull out the negative 2 from negative infinity to positive infinity. So the domain is domain negative infinity up to the negative 2 union with negative 2 and positive infinity. That's a domain. Any question? You know that we did it before. This function is defined because if you put the negative 2, the denominator would be 0. The top would be negative 11. Negative 11 divided by 0, it's undefined. So that's why you have to take out the negative 2 to get the domain of the function. Any question? So that's domain. Next. See, asymptote, we talk about it. Asymptote is the case that the end behavior of this function. The end behavior is, this is x. X can getting bigger and bigger and bigger, a positive infinity. Getting smaller and smaller, negative infinity. End behavior, remember that we did for the polynomials. Then you see the top is a polynomial. If you want to take the end behavior, we take the leading term, 5x. The bottom one is x, and then we can find the result. If you take x goes to infinity and get the result for y, it's going to be a fixed number, y equal to 2, y equal to 3. In that case, that line is horizontal. We talk about it. That gives you horizontal asymptote. Okay, this is when x goes to infinity, we get the y. The other way around, if the denominator getting closer and closer to the 0, it's like dividing a number by 0. If it's going to be a fraction whose denominator is very small, when the denominator is very small, the fraction would be infinity. This means y would be infinity. So that value of x would create a vertical line, you see? If you put x equal to negative 2, the denominator would be 0. So we get the infinity, what's undefined. So that x equal to negative 2 would be a vertical line. That would give us, that we call this one, okay, a vertical asymptote. So one of them goes to infinity, we get the other ones. Now the way we're going to find it, first, if there is a common factor, the top and the bottom, you simplify it. There is no common factor. So we call it reduced form. Reduced form. Reduced form, you cannot simplify it. So that gives you y equal to 5x minus 1 over x plus 2. You get the reduced form first. Then we go for those asymptotes. The vertical one is easy. Vertical asymptote. The vertical asymptote is x equal to, you let denominator equal to the 0. You see denominator equal to the 0. So that gives x plus 2 equal to the 0. So the result would be x equal to negative 2. This is the vertical asymptote. It's going to be a vertical line that would be closer and closer to the function. You see the denominator would be 0 and the y goes to infinity. That's why we call it vertical asymptote. Okay, any question? The other way around, horizontal asymptote. Horizontal asymptote is the end behavior. You see in this case, look at y. Y is equal to the 5x minus 1 and the x plus 2. Remember, if you shrink the y, the top into the 5x, the bottom one into the x, like a polynomial. This x and x would disappear, that gives you 5. Y equal to the 5 is horizontal asymptote. And you're done. Any question? There are 3 cases, depend on the degree of the top or the bottom one. And we are going to, there is something we call it a slant asymptote. We are not going to have it for this test. So you must make one of them infinity to get the other ones. Vertical asymptote is you let the denominator to be 0. So anything divided by 0, y would be infinity. That's why we call this one vertical asymptote. The other one is when we get the end behavior, remember when x goes to infinity. X goes to infinity, we get the y. So this is going to be horizontal asymptote. Both of them are going to be used when we want to graph it. We are not going to graph it for this test, okay, because we want to make things sure we have time to practice. That's the case 1. Any question? What is the case 1? Look at the degree. 1, 1. The
I have a
degree of
question
the
real
top
quick.
and the bottom. Yes, question.
For the horizontal asymptote,
Yes.
we're just like disregarding the -1 and the 2
Yeah.
because it's going to infinity?
That's it, yeah.
Okay.
Yeah, we shrink it, like a polynomials. Very good. That's the case 1. Question. Case 2, the degree of one of them is going to be higher. Let's take the bottom to be higher. So this is g of x equal to, the top is going to be x plus 3. The bottom one would be x squared minus 4. Look at this one. Okay, again, domain first. Domain. You know that. You have to factor the denominator. So that would be what? I write it down. G of x equal to x plus 3. This is x minus 2 times x plus 2. So the number is going to be 0 at 2 places. 2 places. So you have to exclude this is a negative infinity. Exclude the negative 2, positive 2, and that's positive infinity. 1, 2, 3. The domain, negative infinity, up to the negative 2, union with negative 2, positive 2, union with 2 and positive infinity. That is the domain. Any question? We did it before, you know that denominator cannot be 0. Denominator cannot be 0 because we get the fraction would be undefined. Question? That's case 1, first part. Second part, check to see if we can simplify it. There's no chance, no common factor. Okay, I just write it down, just remind yourself. Reduced form. You cannot simplify, so we call it y equal to, that's it, x plus 3 over x squared minus 4. So we continue. Vertical asymptote start with the x, denominator equal to the 0. Okay, denominator is 0, y would be infinity. So vertical asymptote. Okay, ready? Vertical asymptote. This is it, vertical asymptote. Let the denominator to be equal to 0. Just remind you, the denominator equal to 0. The factor form was x minus 2 times x plus 2. We get two lines, x equal to negative 2, 1, x equal to positive 2, the second one. Done. Any question? Don't write VA equal to 2 and negative 2. Doesn't make sense. Line. Okay, vertical asymptote. Vertical line start with the x. Some people write VA equal to positive negative 2. Doesn't make sense. We need a line. Any question? That's vertical asymptote. Horizontal. This is when x goes to infinity. End behavior. Bring the function. What is the function? X plus, okay, x plus 3 on the top, plus 3 on the top, x squared minus 4 on the bottom. Shrink it. Remember, when it goes to infinity, the top would be x, the bottom one would be x squared. Simplify. 1 over x. Let's see what is this one. You see, when x goes to infinity, remember we did this one before. When x goes to infinity, the bottom one is infinity, the top is 1. It's like we have a pizza on the top. You want to divide it into infinity many parts. If you have a family pizza divided into 20 parts, your share would be nothing. If you divide by infinity, this goes to 0. Okay, this goes to 0 as x goes to infinity. Okay, so y equal to 0 is going to be your horizontal asymptote. Any question? In your book, of course, they don't use this method, and I accept it on the test. In your book, they tell you that if the degree of the bottom is higher, y equal to 0 is horizontal asymptote. Right away. I just want to know the reason really, okay? But you can use it if you like. So when the degree of the bottom is higher, there is going to be leftover than the denominator, x. Leftover means infinity. Infinity, okay? We call it the pizza problem in calculus. So you have a pizza on the top, 1 on the top. You see, if you have a pizza divided by 20 parts, 30 parts, 100 parts, so the result is nothing. So in this case, just pick with whichever you like. Give us y equal to 0 right away we accept it, or just explain it for us. Because your book, they give you this, quick way to do it if you like. Any question? So when the degree of the bottom is higher, horizontal asymptote is 0, and then you're done. That's it. That's case 2. Any question? What's going to be ready for case 3? So what was this one? This one was the one that the degree of the bottom was higher. So how about the other way around? We give you all of them, as one question, or we just change it into 2 questions. Case 3. What would happen if the degree of the top is higher? The top, x cubed plus x minus 1. The bottom one is x squared minus 1. You see this one? Let's see what is this. Solution. Domain first. Domain. You have to factor the denominator. So rewrite it, f of x equal to x cubed plus x minus 1. This would be x minus 1 times x plus 1, okay? 2 places, you get 0. Add x equal to 1, and x equal to negative 1. So we have to exclude these 2 numbers from the domain, okay? This is it. Negative infinity, positive infinity. You don't have to draw it out, but I do it as a negative 1, positive 1. So you have to take these points out. Domain, remember, we want the domain interval notation. Negative infinity, negative 1, negative 1, positive 1, 1, and positive infinity. No bracket, remember. just parentheses because, if you put the bracket, that gives you 0, and then, you cannot have 0 down the denominator. Any question? That's a domain. Can you simplify it? No. There is no common factor. So the reduced form is the same. I just repeat it so that you are not going to miss it. There is only one case. So just have a look, even if you don't want to write it down. Okay, reduced form, just as is. So it's going to be x cubed plus x minus 1, x squared minus 1. Okay, go for the vertical asymptote. Vertical, remember to start with the x. Denominator equal to 0. X squared minus 1 equal to the 0. That gives you 2 points, 2 lines, positive, negative 1. Vertical asymptote. Because the denominator would be 0, so y would be infinity. That's why it's a vertical asymptote. Question? Horizontal. You see the degree of the top is higher, so it's going to be left over on the top. So let's shrink it. It's x cubed plus x minus 1, and that would be x squared minus 1. If you shrink the top, that gives you x cubed. The bottom one gives you x squared. If you simplify it, that gives you x. You see, when x goes to infinity, this goes to infinity too, as x goes to infinity. So this means there is no horizontal asymptote. The cases, we call it a slant or oblique, but we are not going to talk about it now. So if the degree of the top is higher, there is no horizontal asymptote, okay? Horizontal asymptote. Or you can say none, we accept it. In your book, again, they give you a shortcut, a theorem. They say, oh, if the degree of the top is higher than the bottom, there is no horizontal asymptote. That's your book. And we have to accept it, if you do it on the test. But it's nice really to know the reason. When you shrink it, the degree of the top is higher. So there's going to be an x squared to the third, to the fourth. So we get infinity, infinity. When x goes to infinity, y goes to infinity. So in that case, there is no horizontal asymptote. And that's case 3. Any question? So it's a 3 cases, you see. If the degree of the bottom is higher, okay, this is the top. If the degree of the bottom is higher, there's going to be left over here. So horizontal asymptote would be 0. If the degree of the top is higher, infinity would be on the top. So there is no horizontal asymptote. Just make sure to know. You don't, you get it right. Any question? That's a test case. There's another one. What is the other one? You see this reduced form, reduced form, reduced form. So what would happen if you have to reduce it? Okay, so that's 4 cases. We put them together as 1 or 2 questions. And it's very easy. We get it right away. Okay, so 1 with the common factor, if you like. This is it. X minus 3 on the top, x squared minus 9. The way you do this one, the order of your operation is very important to not miss any point. Now let's see how we're going to do it. Domain first. Without domain, you're not going to go on. Domain first. To get the domain, we have to factor it, okay? So factor it, factor the bottom one, you see. F of x equal to x minus 3, x minus 3 times x plus 3. You must make sure that don't simplify it now. Some people simplify that. If you simplify now, your domain would be different and you will lose everything. Just find the domain, okay? The domain is when the denominator is not 0. You are going to have 2 zeros. X equal to 3 and x equal to negative 3. So exclude these numbers first, okay? So this is it. You don't have to give us a graph, but it's a -3, you see, and the +3. So you have to exclude these two numbers. So go for it. What's going to be your domain? Domain -infinity to -3, union with -3 and +3, union with 3 and +infinity. Okay, make sure you use these parentheses, not bracket. That's your domain. Any question? Now, you see, reduce form now. In this order, reduce form. Reduce is possible because it's a fraction. You know, any fraction at any level, you have to reduce it. It's possible. So this is it. We have a common factor. Now this is the time you are going to exclude that common factor. The top would be 1, so y equal to the 1 over x plus 3. From now on, you go with this one rather than the original one. Any question? Okay, so you have to reduce it, but after the domain. Some people simplify it. They start with this, and they say that the domain is all real numbers except -3, which is not correct. It's all real numbers except -3 and +3. Just make sure don't miss it. Okay, any question? Now continue. Vertical asymptote easy. Denominator equal to the 0. So that give x equal to -3. Done. Okay. Horizontal asymptote. And behavior, shrink it. And you know that the degree of the bottom is higher. It's 0. Right away, but if you want to shrink it, the top is a pizza, the bottom one is x. You know that this goes to 0. Okay, as x goes to infinity, if you want to explain it. So y equal to the 0. And you can say y equal to the 0 right away, we accept it because of your book. Okay, so make sure to simplify it if you give any chance. That's it. That is the domain of the asymptote. And after your test, we're going to give you, the graph of the function. It's in 4.2, the graphing one. Okay, any question? So don't miss it. Now we can quickly go to the problem that you have on that practice one, similar to this one, and we just try it. Okay, so this is the one that we didn't get time to talk about it the other night. It's a straightforward problem, just don't miss it. Okay, ready? Go to the practice test. I do that asymptote first, because we just talked about it. So this is practice test number 2. You know that 11 question, you answer 10 on Wednesday as usual. PDF file in the canvas, just submit it and then be done. So we are going to get to number 4 first. This is what we did. They asked for the domain and all possible asymptote. Okay, so find the domain, and all possible. They say vertical, horizontal. I just write it for possible asymptote because you automatically that you have to find these possible asymptotes. Okay, this is going to be one asymptotes. 3 cases. Okay, the first one, case 1, y equal to, 3x plus 1, x minus 2. You see, this is the case that the degree of the top and the bottom is the same. Everything would be nice. Okay, we are going to have horizontal asymptote, vertical one. Are you ready? Domain is easy. We have only one factor, x minus 2, so we have to exclude the 2. Okay, solution. We go for the domain first. Domain. That's it. The denominator is 0 at one place only. So the domain would be negative infinity up to the 2 union with 2 and positive infinity. We have one number to take out. Any question? Because we have only one factor. Each factor will give us one number to exclude. Then you check to see if you can reduce it. Reduce form, no. There is nothing to simplify. So we stay with what we have. 3x plus 1 over x minus 2. Okay, that's a reduced form. Now go for the asymptote. Easy one, the vertical. Denominator equal to the 0, x minus 2 equal to the 0. That gives x equal to 2, done. One way. Remember, we need a line. Don't write equal to 2. Doesn't make sense. Okay, that's the vertical asymptote. Horizontal, shrink it. It's a y equal to the 3x plus 1, x minus 2. We shrink it into the 3x over x. You simplify the x, 3. Y equal to the 3 is going to be horizontal asymptote, and you're done. Any question? That is, okay, that's case 1. You see, the case 1 is that the degree of the top and the bottom is the same, you see, it's the same. That's case 1. Okay, ready for case 2? Case 2, B. Let's see what's special about this one. Y equal to x minus 1, x cubed minus x. You know that. You have to factor the denominator first. It's x cubed minus x. You factor it out to get the domain. Okay, and be patient. So the solution, we go with the first part, the domain. Okay, I'm going to factor this one separately, x squared minus x. You know that the common factor would be x. So that gives us x squared minus 1. Then you have to factor it again. So that gives x times x minus 1 times x plus 1. Now you know that. You are going to have 3 numbers to exclude. 0, 1, negative 1. Okay, exclude negative infinity, positive infinity, negative 1, 0, and 1. So 1, 2, 3, 4. We have 4 partitions, so the domain is going to be equal to, remember, there is a common factor, but make sure don't simplify it. Okay, it's going to be negative infinity to negative 1, union with negative 1 and 0, union with 0 and 1, union with 0 and positive infinity. Okay, we have 4 partition in this case.
Would it be 0 in infinity or 1 in infinity?
Oh, you are right. It's 1 and infinity. Thank you.
Okay.
1. Very good. Okay, negative 1, yes. Any question? So that is the first part. For going to the second part, you know that reduce form all the time after the domain, not before. Okay, domain first, then you should have a domain first, you see? Then you can talk about it. So we go with the reduction form if it's possible. Okay, so we check reduced form. Okay, this is it, reduced form. Now we bring those factoring part. So x, the top was x minus 1, and you already factor it, x times x minus 1 times x plus 1. Okay, that's the case. So we have a common factor, we eliminated it. Okay, you eliminate it, so your reduced form is going to be 1 over x times x plus 1. That's it. From now on, you are going to continue with this one. Okay, any question? Go for the vertical asymptote, which is easy. Denominator equal to the 0, that give you two solutions. Okay, x times x plus 1 equal to the 0. So that give you x equal to the 0, 1, and x equal to the negative 1, the second one. Two vertical asymptotes. If you don't simplify it, you are going to give us three vertical asymptotes, which is not correct. Okay, any question? So this is going to be the case. Horizontal asymptote. You see, you shrink it, or quickly you can say that the degree of the bottom is higher, so it's 0. Okay, even if you shrink it, you see, if you shrink it, so that you 1 over, that would be x squared, goes to 0. You can say 0, we accept that, but if you want to prove it, this is going to be the case. When the degree of the bottom is higher, y equal to 0 is your horizontal asymptote, and we accept it right away without any question. Okay, any question? So be careful about this one, especially the reduced one. There is a common factor, don't miss it. You have to reduce. Yes?
In the last problem that you showed us from the lesson, you said not to do reduced form before you did the vertical asymptote because
Yes, that's correct.
2 lines, but in this one you did reduce it before you did the
No. I said that you have to find the domain first. You have to reduce it, then go to vertical asymptote. No, not this one.
Okay.
No. You see, because automatically after the domain, okay? No, I said not before the domain, not the vertical asymptote, no.
Okay.
Okay, that's going to be 1. So that gives us case 2. Any question? So the last case is going to be the case that we are not going to, the degree of the top higher. Okay, so the y would be, the top is the 3x cubed plus 1, okay, over x squared minus 1. You see the degree of the top is higher this time. So the domain first again, the domain. Again, the denominator, you have to factor it. So we have the 3x cubed plus 1 on the top, and this is going to be x minus 1 times x plus 1. Two numbers to be excluded, 1 and negative 1. Okay, this is a negative infinity. We get a negative 1. We have a positive 1. And it's a positive infinity. So the domain would be start from negative infinity going to the negative 1, union with the negative 1 and 1, and the union with 1 and positive infinity. Okay, that's the domain. Any question? It cannot be reduced. Okay, it's already there because no common factor. Okay, so we reduce, the reduced form is going to be as is. So the y is equal to the 3x cubed plus 1, and that's x minus 1 times x plus 1. Okay, now the vertical asymptote. The number would be 0 at two places, positive negative 1. Okay, you write positive negative 1, we accept that. So this is it, x equal to 1 and x equal to negative 1. Remember, in the line form, not just a number. That's vertical asymptote, and the horizontal one, you see the degree of the top is higher. Horizontal asymptote does not exist. Okay, if you want to shrink it, you shrink the original one, or just tell us, it's going to be the same thing, but it's not bad. Just stay with those shrinking one in case you want to take calculus. Okay, this is it. You can say it does not exist, we accept it. But if you shrink it, that give it 3x cubed over x squared. We simplify the x squared, the left is going to be 3x. That takes us to the infinity because it's not fraction. Okay, so you can say none, not apply, does not exist, none, we accept it. Okay, so there is no horizontal asymptote, and you're done. Okay, that give you an idea. The way we are going to question you this one. You know, it's a long question if we give you as one question. Okay, so be ready for it and write nice. Okay, this is the nice one. You know, I just graded I have a pre-calculus class at university. I have 80 students. I grade their paper. Most of them, you see, they take over here, they write VA equal to the positive negative one. Doesn't make sense. Okay, it's a line, vertical line. Okay, X equal to horizontal line, Y equal to. Okay, be precise. And that's the first question, the new one. Any question besides your quiz? So that was a rational equation, that rational function. And there is another section 4.2, graphing the rational function, that we're going to do it after your test. Now, the other new topics that we did, we just go on as we talk about it. So I'll go back to the question number one is inverse function. We did the inverse, so if we get time, we come back and we take care of it. I just put it so that you know that it's going to be given again as you did it on the quiz. So let's go to the question number two, syntactic method. This is the tool that we need, so we're going to check it. Okay, we check this one question, probably two parts. Okay, so this is going to be number two. We wanted to operate syntactic method. Okay, syntactic division. So this is it, syntactic division. It's easy, but make sure that everything is in order. Okay, we have two here and we check them. Part one is x to the fourth, okay, plus 5x cubed minus 2x squared plus x minus 1. You want to divide it by x plus 1. You know that syntactic one is a short form of the long division. So the way we are going to do it, we drop the x's and we work with the numbers. The first thing to do, you must make sure that the polynomials are in standard form. Standard means if you start with the fourth power, you must have the fourth, the third, the second, the first, the constant. If anything is missing, you will see in the second part that you have to take care of it. This is the first thing. The other one is we drop the x, but we use opposite number. It's like you know that x plus 1 equal to the 0, that gives x equal to negative 1. So make sure to start with the negative 1. Otherwise, it's easy. Negative 1. We're going to put the numbers, coefficients 1, 5, negative 2, 1, and negative 1. Okay, you bring the 1 down, draw a line, and then start multiplying the negative 1 by these results. Okay, negative 1 times 1 would be negative 1. So we add them together, that give you 4. And then you repeat it. Negative 1 times 4 would be negative 1. So that gives you a negative 6. Negative 1 times negative 6 would be a positive 6. That gives you 7. Okay, negative 1 times 7 would be negative 7. That gives you negative 8. This would be the remainder. Okay, this would be the remainder. This is going to be the reduced polynomials or the quotient. You have to tell us what it is. Since you divide by x, so the result, the quotient is going to be, the degree is going to be 1 dot. So this is x to the 4th, this is going to be x to the 3rd. So 1x to the 3rd, x cubed, plus 4x squared, minus 6x plus 7. If you write this one, we accept it, but we prefer this one as a quotient. Okay, plus 5x cubed minus 2x squared plus x minus 1 be divided by x plus 1. The quotient is x cubed plus 4x squared minus 6x plus 7, and the leftover. The leftover is going to be is a plus the leftover on the top, which is a negative 8, divided by x plus 1. That's the best way to write it down. Okay, you can put this negative up front. We don't mind. Any question? Don't leave it. Some people, they leave it as is. You won't get the point, all the points. So we need a question. Nicely, just rewrite it. This is the final answer. Okay, this is going to be the final answer. Put this negative down here. Any question? That's part one. No change is needed. But the type 2, you may have to change it a little bit. Are you ready? Let's see what is special about it too. Part 2, you have x to the 5th, okay, minus 4x squared, okay, plus 4x plus 4. Then you want to divide it by x plus 3. That's it. Again, you check to see if everything is all right. The 5th. So you need the 4th. You don't have it. You need the 3rd. You don't have it. Then a squared x1. So you have to rewrite it. For those missing, you add 0 if you like, okay? You see this the way we write it down? This is x to the 5th. If you don't have the 4th, write plus 0x to the 4th. You don't have the 3rd, write 0x to the 3rd. So then we get the x squared and the x and the constant. You see? Make sure to know. If you miss it, you're out. Because you know that. You see? When you want to write the final answer, you need a representative of each power of the x. So make sure you get it right. Okay, any question? So it doesn't matter how many terms are missing. You just add these zeros for the missing one. So you want to divide it by x plus 3. That's it. You use the negative 3 into those coefficients. So you have the 1, 0, 0, negative 4, 4, 4. It's a coincidence, we get lots of 4s. Okay, this is going to be the case. Now you bring the first number down. Okay, first number down, and then you are going to continue. Negative 3 times 1 would be negative 3. You add it to the 0, that gives a negative 3. Okay. Then we continue. Negative 3 times negative 3 would be a positive 9. So that gives us a 9. Then that gives you negative 27. Okay, that gives you negative 31. And negative 31, that gives you positive 93. It's going to be 97. Okay. Then you multiply by negative 3 again. So that gives you 3 times 7 would be 21. Okay, and that's going to be, I think, 291. Yes, that's it. 3 times 7, 21. 3 times 9, 20. That's 21, yes. Then you subtract it. Okay, if you subtract it, that gives you 287. Okay, so that's going to be the remainder. That's going to be the remainder. It's going to be the leftover quotient. And the quotient polynomial, you start with the 5th. You divide it by x, so this must be 4th. So that gives x to the 4th minus 3x to the 3rd plus the 9x squared minus 31x plus 97. And that's what we find. We accept it if you write it, the quotient and the remainder. But you can, if you like, you can rewrite it. divided by x plus 3 as the quotient. You repeat this one, x to the fourth minus 3, x to the third, 9x squared minus 31x plus 97, the leftover. Leftover is negative, so it's going to be minus 287 over x plus 3. Yeah, it's a nice. You know that if there is going to be 0, it's going to be just divisible. So be careful. If some of the terms or a term is missing, make sure that you repair it before going to the to your division. Otherwise, your operation would be totally totally different and incorrect. Okay, any question? So that's synthetic method. We give you one question, two parts, because that's our tool. Okay, it's a tool, so we want to make sure that you are ready to to operating. Okay, so that is question number 2. Question. Now the application. What is the application? Solving an equation for us. Remember, if we divide and the remainder would be 0, so we are going to have a factor, if you like, or a 0 of of an equation. So we give you a couple of equations and we ask you to solve it. We may give you 1 or 2. So this is where we would like you to use that rational 0 theorem to find one of the solution and just keep going. So let's try. This is number 3. We want to solve each equation. Okay, that's a big deal. That's the one that we use in calculus, really. That's the purpose of all these operations that we did. Okay, so we usually give you one with the lower power is going to be x cubed, and one with the higher power we do x to the fourth. So expect one question but 2 parts. So this is it. Solve each equation or find all zeros. Solve each equation. So when we say solve each equation, you have to find all the solution for us. Rational, irrational, complex, whatever it is. So the first part, the equation is, this is it, 2x cubed. Okay, 2x cubed minus 11x squared, 11x squared plus 10x plus 8 equal to the 0. Okay, this is going to be the case. So remember, we have to find one of the solutions. Then we use a synthetic method to reduce it into the square, and then we can take care of it. Now, the way we're going to find it, remember, this is the one. The constant term is going to be 8, a0, and the leading term would be 2. So the solution, if this equation would have a rational solution, the solution is going to be x equal to the p over q. Okay, just remind you that the p is factors, just to remind you, factors of a0, and the q is factors, factors of an. Constant term goes on the top, don't miss it. Okay, a0 is 8. Then you check 8 is divisible by what? Divisible by 1, 2, 4, and 8. So just use positive negative. So it's going to be positive negative 1, positive negative 2, positive negative 4, and the positive negative 8. So these are going to be divisors of a0. The bottom one, divisors of an. An is 2. You know that divisors of 2 are going to be positive negative 1 and positive negative 2. Positive negative 1 and positive negative 2. These are going to be 1. Okay. Then you divide. You know that divide all of them by each of these numbers as listed. So the x is going to be equal to, divide. If you divide all of them 1 by 1 by 1, they give you the same one. So that give you a positive negative 1, a positive negative 2, a positive negative 4, a positive negative 8, okay? And then you are going to divide it by 2 again in case you get more numbers. Okay, so each one of them divided by 2. 1 divided by 2 would be 1/2. Okay, 2 divided by 2 would be 1, that you already got it. 4 divided by 2 would be 2, we already got it. And 8 divided by 2, that give you 4, we already got it, okay? So there is no new members. Okay, so there you are. So these are possible solution, not the solution, possible one. Okay, it's going to be possible, so you can try to find at least one of the solutions from here. Okay, you have two choices. You can drop these numbers into the equation to check it, or you can use the syntactic method. Okay, so we talk about it for the one is easy. If the sum of the coefficients are going to be 0, because if you drop the 1, this x would disappear. So we get these numbers 2 minus 11 plus 10 plus 8. So it's not. So you're not going to check the 1. You may check the negative 1 to see if it's going to be the case. Okay, just you need one of them. If you check the negative 1, it's going to be 2 negative 11, and that gives you 10 and 8. Okay, and what you bring the 2 down. Okay, and then start multiplying. So that gives a negative 2, which is going to be negative 13. Okay, so that gives you, which is not, yes. So that gives a negative 2, negative 13. So that make it into the 13, which is a 23. So it's not. Okay, so this is not going to be the case. Okay, so 1 and negative 1 is out. You know, it depends how quick you can find it. You can try 2 or negative 2 to see if one of them is going to be the case. So which one is it? If you take 2, okay, and we have a 2, negative 11, and 10 and 8. Okay, you bring the 2 down and then you try it. So they give 2 times 2, 4, so that make it the negative 7. Okay, that give you negative 14, which is going to be a negative 4, and that give you negative 8. So this is one of them. Okay, so x equal to 2 is the solution. Okay, x equal to 2 is a solution. And you know that x minus 2 is a factor, and then you can use this one. So this means your f of x is going to be equal to x minus 2 as a factor times, okay, 2x squared minus 7x minus 4. Okay, you did this one to be equal to the 0, and you continue. Okay, so the leftover is 2x squared minus 7x minus 4. You can factor it. You can use quadratic formula, okay, to find your solutions. It doesn't matter. Okay.
Can
Any
you still
question?
use substitution for that?
Yes. Do you want to use it? Yes, we can try. You see, the other numbers that you have are going to be, yeah, if you use the substitution, you have to use those leftovers. Okay. So what we need, we can try 4, okay, to see if this is going to be the case. You see, if you want to try 4, you already got these numbers. It's going to be 2, negative 7, and the negative 4. If you bring the 2 down, so that give you 8, which is 1. Okay, and this is 4, you see? So this means x equal to 4. Remember, you are going to check it into the reduced polynomial, not original one. Okay, so that give you x equal to 4 is one of the solution. Okay, is a solution. And what's going to be the leftover? You see, the leftover is what? 2x plus 1. So your f of x would be x minus 2, x minus 4, and the last one, look at the last one. It's just a 2x plus 1. Okay, and you got the last solution that you need. So 2x plus 1 equal to the 0, so x would be -5. Okay, so as soon as you find the first one, in case of cubic one, you have many choices to get those numbers. Okay, quadratic, yes, because that unless this is a bad one. Okay, this leftover, remember, you may get the leftover that's not going to be having rational zeros. Okay, so you may get a radical solution for this one. So that's a chance. That's why, sometimes it would be safe to check the quadratic formula quickly in case you don't have any nice solutions. But you can try, yes, just a couple of numbers. Okay, any question? So we give you one cubic one. This is going to be one cubic one. It takes a little bit time sometimes, but it can be done. Okay, there is another cubic one which is easy. So I go with the part C first, get that x to the fourth, and then if you get time, we try the other one as well. Okay, so what's question? So no, we do all of the solutions. No. You see, you find one of the solution to keep you going. You see, you've been asked to, you use this method. Yes, you use the method to find one of the solution. You see, you need to find all the solutions. All the solutions. But the idea is when it's a cubic, if you can find one of them, the leftover is quadratic. So the quadratic one, you can take care of it, okay? For the quadratic one, you can use it. Unless the degree is higher, like the next one, okay? Yes, the first one is the key. Any question? So that's cubic. Be prepared for one with a higher power, the fourth. So let's check the fourth one. It's part C. The part 2 is just a cubic again. If you get time, we come back and we do it. Okay. So let's see what is going to be the solution of this one. 3x to the fourth. Okay, minus plus 7x cubed minus 12x squared. Okay, minus 14x. This one takes a little bit more time because you need two solutions to be able to reduce it because this is the fourth. Okay, so let's try. We have to check the possibilities first. So this is it, solution. So your A0 is 12. A0 is 12 and the AN is equal to 3. Okay, check the possibilities. So your X is going to be PQ. Okay, the P is the divisors of 12, which is quite a lot. Okay, divisors of 12 are going to be what? Is a positive -1, positive -2, positive -3, positive -4. What else? Positive -6, positive -12. So on the top are going to be divisors of the constant term. And the bottom one is going to be divisors of the 3. Divisors of 3 is going to be positive -1 and the positive -3. Okay, any question? So on the top, the divisors of the constant, which is 12. Down the bottom, it's going to be divisors of the AN. Now divide all of them by the bottom one by 1. If you divide all of them by 1, the result's going to be just simply the same. Positive -2, positive -3, okay, positive -4, positive -6, positive -12. Okay, these are going to be the 1. Then you have to divide by 3. 1 divided by 3, that gives you positive -1/3. Okay, that gives you positive -2/3. If you divide the 3, you get it 4/3. That's a fraction. 6 divided by 3, that gives you 2. You already got the 2. And the 12 divided by 3, you get the 4. So these are going to be the possibilities. You need 2 of these.
Is there any way to narrow that down instead of doing like 100 math problems?
Yes, but these problems are now not going to be difficult to
Okay.
get those numbers, okay, because degree is 4. Yes, but in general, yes, but not much really. But it's in this case, you need a couple of them to get. But if the degree is going to be something like x to the 100, yes, okay, because you're being expected to find 100 solutions, you can do it. Okay, there you are. So I think this is one of the problem. I don't know where I got this one, but we can check. Okay, check the one quickly to see if this is going to be the case. The one that give you 10, okay, it's going to be 10, and that is going to be 22. Okay, so the one would satisfy this one. If you put x equal to 1, you see, you put x equal to 1, you check the sum of the coefficients, because when the substitution, if you get, is going to be 3 plus 7 minus 12 minus 14 plus 12. Okay, so the 12 and 12 would, oh, is not? 3, 7, 14. How do you get this? 1022? Yes, it is. Yes, 1020. Yes, it's going to be the case because that is, oh, it's going to be this. It's going to be 20, 26. 26 is not. It's not because that give you, no, the one and the one is not. Okay, one is not. Okay, so you may check the negative one. Negative one is also easy to check if you like. If you check the, or just the, if you check the negative one, just give you different options so that you know it. The negative one that make it 3 here. This is make the different signs. It's going to be negative 7. It would stay the same. Okay, stay the same. And this would be a positive 14. And this is going to be 12. Okay, and this is it. No, it's not going to be. Negative 1, positive 1 is not going to be the case. Then you have to check one of these numbers, okay, to see which one is the case. Okay, you can try. Okay, which one is it? I checked the 1 and negative 1. I have the solution, but so check, check 2 to see if this is going to be the case. There was something special about this number that I put it over here. It's going to be 3, 7. Okay, minus 12, negative 14, and the positive 12. Okay, if you're putting the 3 down, so this is going to be 6, which make it to the 13. Okay, that give you 26. Okay, the 26 is going to be, is it 14? Okay, that make it to the 28, which is going to be 14. It's not. Okay, this is not going to be the case. So what else? If you pick, I think that's going to be 3 maybe. So this is 3, 7, negative 12, negative 14, and the 12. So if you bring the 3 down, so that it make it into the negative 6, which is 1. So that give you negative 2, which is 14. Okay, negative 14. So that give you 28. Okay. This is not. Which one is it? Okay, try 3 to see if this is going to be the case. And then put it those numbers. Try to see which one is it for the numbers. Just did you find any number? It was something else in your original one. I changed it into this format. Just there is something special about this one, that I pick this one. Any number for this one?
-3 works.
Yeah, it does. -3.
I think so.
I think it was one of these fractions that I like this problem that I put. Maybe nothing would work on that one. Okay, so let's see if you are. This is 7 and -12. Okay, and they're negative 14 and 12. On the test, we give something that's going to be straightforward, but not bad. So that give a -2, it's going to be 6, which is a -6 is going to be 18. Yes, yes, you are right. Very good. So x equal to -3 is one of them. Okay, and the leftover. So that give you x plus 3. Okay, x plus 3. So you know that we start with the fourth degree, so it's going to be cubed, 3x cubed minus 2x squared minus 6x plus, okay, plus 4. This is going to be the leftover. Okay, then you have to work on this leftover to see one of the other solutions that you're going to have. Okay, I think 1/3 is going to be the one that would take care of this one for the 3x squared, because we already checked all those numbers. Okay, so it's going to be 4, 6. I think 1/3 is, let's just try the 1/3. Yes, do you have anything for this one?
Can you redo p over q for this second portion, the 3x squared or
Yeah,
cubed?
yeah. No, you say the solution going to be the one that you have. You don't need to do it again. See, these solutions, when you reduce it, it's the same thing. So you arrive at the same thing. You want to, yeah, I know what you mean. You restrict those, no. It's going to be just one of these solutions again. Okay, so just check the 1/3. How about 1/3? Maybe that's why I picked this one. I don't know. There was a reason that I put this one in the conclusion. Okay, if you pick the 1/3, so 1/3 times 3 would be, okay, 1/3 times 3 would be 1. That they get -1. Okay, so this is going to be the case. Let's try -1/3. -1/3, so make it into the -3, then you multiply together. Okay, that give you 1. Okay, so if you multiply together 1, that give you -5. No, it's not. I'm surprised that this happened to be, what was the number? That's why you should try it to get this number, which is, let's see where I get this one. This is one of the problem from, we had it in calculus. So that is why I put this one here, so that we can get it right away. But maybe any solution, any more solutions of this one? Okay, we give a break. Okay, that's it. And we come back and we do it. Then I check it myself, and then we continue. Seems to be all right, but I can get it. Okay, 10 minutes. This is 8:30. Come back in 8:40. Okay, and we continue getting these numbers. I check Okay, so the number was 2/3. I just check it. You see, this is going to be the one. If you try the 2/3, you see, instead of a 1/3. If you try the 2/3, this is going to be 2/3. Remember, 3, -2, -6, 4. If you substitute over here, 2/3 times 3, that make it do the 2. 2 and -2 would be 0. 2/3 times 0 would be 0. 0 and -6 would be -6. And 2/3 times -6 would be -12 over 3, which is a -4, so that make it 0. So x equal to 2/3 is going to be the second solution that we've been looking for. And the leftover is going to be 3x squared minus 6 equal to the 0. 3x squared minus 6 equal to the 0. You know that you divide by 3, x squared minus 2 equal to the 0, x would be positive, negative, radical 2. So the solution of the equation is going to be, we have x equal to the -3, x equal to the 2/3, and x equal to the positive, negative, radical 2. Okay? This was, I think, somewhere in your book. I couldn't find it. That I just saw it and just wanted to see it. But the one that we give you on the test is going to be, it's not going to be lots of roots. You'll be able to find it quickly. But it's not bad, to know that you got to be patient to be able to eventually get one of those roots. Okay, any question? So this is it. You see, these are the possibilities and the way you are going to get to this. And there's too many solutions, if you like. But we give you something that's going to be shorter. But it's not, it's possible. It's possible, but we have to try to get those numbers. Okay, any question? So you check the 2/3. The 2/3 will take you back to the easy equation. 3x squared minus 6 equal to the 0. And I just, just factoring or just divided by 3, that give x squared minus 2 equal to the 0. So x would be positive, negative, radical 2. So that was question number 3. Okay, so one question on the syntactic method, 2 parts. One question in solving the equation, again, 2 parts. One cubic and one, it's going to be 4th degree, but you'll be able to find that one. So question number 4 was finding those vertical asymptotes. Okay, now let's go back to this question number 6 first. It's easy question. You want to graph a polynomial function. This is where you have to find those in behaviors and the x-intercepts. Okay. And this question is easy, but we want to make sure that you get it right in writing. So that's question number 5 here. Okay, graph the polynomial function. Okay, sketch the graph. Okay, sketch the graph of a polynomial function of each polynomial function. It's easy, but I want to show you that how you are going to write it down to get the full grade of this problem. Okay, do a couple of them. The part 1, the function is f of x is equal to -5 x to the 4th, okay, times x minus 1 times x plus 3 all cubed. Remember, to graph a polynomial function, it's 2 steps, and you have to write it down for us. One of them is the end behavior, when x goes to positive infinity, negative infinity, and the other one is going to be intercepts. For the intercepts, you let it equal to 0. Each factor would be 0. And then we talk about it. The graph of the function can touches the x-intercepts or can crosses. It touches if the degree is even, crosses when it's going to be odd. You identify these two and then you graph it for the 10 points. Okay, so it's 2 steps and you have to write it down for us. If you just graph it, we give you 5 out of 10. And we need especially these two parts, especially the first part, which is very useful in calculus. Okay, so this is the case, the first part, end behavior. End behavior, you check those infinity. But you check it, remember, in the leading term, the term containing the highest power of x. So you are going to rewrite it. To get the leading term, we multiply each term with the highest power of x. The first one stays the same, negative 5x to the fourth. The highest power of the second term is just x. The highest power of the third term is x cubed, x cubed. And there are some other terms that we don't care, the leading term. Okay, so this f of x would be negative 5x to the, you add the exponent. You have 4, 1, and 3. 4 and 1 would be 5, 5 and 3 would be 8, and everything else. Okay, remember, we shrink it and we check the infinity. So f of x is like negative 5x to the 8. That's a crucial part. You check the infinity, just the sign. If x goes to negative infinity, that would imply that f of x or y goes to, what is the sign, positive or negative? You see, you check the power first.
Negative.
Negative. Negative to the 8, you see, negative to the 8 would be positive, but there is a negative outside. So that
Wait,
make it into the
why is it
negative. 8 because we add the powers.
Shouldn't it
Okay.
be 7 then?
No. There's one here.
Oh, there's another x right there.
Oh, just make sure you get the x. Yes. Okay. So check the infinity, the sign first. Negative to the 8 is positive, but there is a negative outside. So that's a negative infinity. Okay. We check the other end. If x goes to positive infinity, x goes to positive infinity, y goes to positive to the 8 would be positive, but again there is a negative here, negative infinity. So that gives you the idea for the starting point at the end of your graph. Okay, you know, if you want to get a preview for yourself, this is it. This is a negative, positive, and this is a positive and the negative. So you see, you start with the negative, negative. Negative, negative is here. So, and this part you go down. At the end, positive, negative, positive, negative. Again, you go down. So this must be the format of your graph. Is going to be down, down. So that will help you for the when you want to do it. Any question? So that's the end behavior, infinity. This part, you know, if in case you take calculus, would be very useful, shrinking one. The next part is intercepts, x-intercepts, x-int. You let each factor to be equal to the 0 to identify touches, crosses. Okay, f of x equal to the 0. The factors, you see this is it. The first factor is negative 5x to the fourth 0. So that gives x equal to the 0. The power is even. So at this point, the graph touches the x-axis. Means it bounces back. You see, that's what. Even touches, odd crosses. The next one is x minus 1 equal to the 0. X equal to 1. So the power is odd, just raise it to 1. So at this, you are going to cross. Okay, and the last one is x plus 1 cubed equal to the 0. So x would be negative 1. You see the power is odd, you crosses. That's it. So even power touches, odd power crosses. Now we are ready to graph it. We know where to start and where to end. You identify these intercepts. You see that's going to be the one. You have 3 intercepts, negative 1, negative 1, 0, and the positive 1. That's it. So you know that at -1, you are going to crosses, okay, touches crosses. Where to start? You know that. You're going to start from here. So you start from here, you cross the -1, you cross, then you nicely turn, you go to the next one. And the next one, at the 0 touches, you touch and then you come back. Okay, then again you go to the 1. And you know that at 1 you crosses. You crosses, you go down. Crosses, you go down, and you're done. You see, it's easy function. And some people, they miss this part. And they miss that the negative positive, so the graph would be something quite, quite different. Okay, that's any question? So let's see if you have a different case, because that was the 8. We get, let's try the second part. I want to get different power over here. So the second part is the same. So I do the part C, which is different. Any question? So remember, this is the way you write it down. Okay, 3 parts: and behavior, intercepts, and the graph, 10 points. Okay, we give you one even on the final, this type of graph. So let's try another one. We give you only one of these. Okay, let's see if this one is different. 5C. 5C is f of x equal to the 2/3 x squared. Okay, x plus 2, everything to the third, and the x minus 2, everything to the second. Okay, let's try this one too. First, end behavior, to get those leading term first, and behavior. Okay, just that's it. F of x equal to, you bring the first one 2/3 x squared. The second one, highest power of the x is x cubed. This one is x squared. X squared. Okay, there are something else that we don't care. Add these powers together, so that give you 2/3. Okay, 2/3 x to the, okay, that give you 5, 7. So that's f of x. You shrink it if you like to these terms only. Okay, get the highest power of the x and then you put them together. Now check the infinity. If x goes to negative infinity, then y goes to, check the sign first. You see negative to the 7 power would be negative. Outside is positive number, negative positive would be negative. Okay, the power first, negative to the 7 is negative. Outside is positive, so it would be negative. Okay, the other way around, x goes to positive infinity. Y goes to, positive to the 7 would be positive, and the 2/3 is positive, so it's going to be positive infinity. Okay, you preview it for yourself. Would be useful, if you want. It's a negative infinity, positive infinity, and that's a positive, and that's a negative. Okay, so what we have, negative, 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 down, positive, 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 up. See, that gives you the idea that you have to have, your graph must be in these 2 quadrants to get these numbers. Okay, any question? X intercepts. Okay, x ints. You let each factor to equal to 0, identify as touching or crossing. The first factor is 2/3, 2/3 x squared equal to the 0. that give x equal to the 0. The power is an even number, so you touches the x-axis at this point. Okay, the second factor is x plus 2 to the third. Okay, to the third, so x would be what? Negative 2. The power 3 is odd, so in this case you are going to crosses. When it's odd, you see you can have a positive number or a negative number. That's why it crosses. When it's even, there's going to be only a positive sign. Okay, and the last one, x minus 2 squared. So x would be 2. Again, the power is even. You are going to touches the x-axis. So 2 touches, 1 crosses. Get the xy coordinate. You see this is it, xy. So this is going to be negative infinity, positive infinity. You know this. You already identify it. Get these numbers. You have negative 2, positive 2. This is a negative 2. This is 0. This is a positive 2. You know crosses and touches, and you know that you have to start from here. Okay, you start from the third quadrant. So you go to the negative 2. At the negative 2 is crosses. So you cross the negative 2, you go to the 0. So this is going to be the case, okay? So you cross this one, you turn nicely, you go to the 0. Okay, at the 0, you are going to touches. So you touch, okay, you touch, you bounce back. Then you turn, you go to the 2. In the case of the 2, you touches. You know that you touch and you have to get back, and you know that where to end up. So this is going to be the graph. You see, this prediction is very important to know that where you are going to end up. Okay, so 2 touches and the crosses. Make sure you have a small turning point, okay, so that you are not going to get any sharp corner. Okay, it's quite interesting argument and one question. Just write it down nicely. You see, give us all this information to get your points, the 10 points. Okay, any question? So that's the only question, one question on these polynomial functions. Okay, so that was a polynomial function. And we get the vertical one. Now we get to that to the rational function. Quadratic function. This is the one that you did. To see, we give you one question, 2 parts, finding the vertex. Finding the vertex, excess of symmetry, like the one that you did. We give you 2 questions on that part, but we put them together and we give you 1 question, okay? But we give you 1 application problems, okay? 1 application problems in applying the quadratic function, okay? For the maximum and the minimum. It's going to be a kind of everyday life problems, okay? So I have one over here is about, the corn plants from agricultural school, but basically this is, I'm going to make a short argument of this problem and tell you that what you are going to do. Okay, are you done? So 1 application problem. It's going to be, in future, you're going to have a cost function. If you're going to be measuring business, they give you the cost, the revenue function. But at the moment, we just give you something from everyday life. Okay, so this is a number 7. Okay, they talk about we are, in the agricultural school, determine the number of the corn plants per acres. So basically, a function would be given to you. So I summarize this one. This is the function, y of n. Okay, this is going to be the case. N is the number of the plants in 1,000 plants per acres, okay? And the yn is going to be the yield bush, okay? Okay, the result, if you like. So the function is this one. It's going to be decimal function. So be patient in applying your calculator, getting the result. So that would be n squared, okay, n squared plus 8.32n, okay, and plus 15.1. Okay, that's a model that you're going to have. N is going to be number of the plants that you're going to have in, in 1,000 plants, corn plants in a farm, in acres, and yn is going to be the result, if you like, those, okay, that the one that you've grown, whatever it is. So the question that we are going to have is, we are going to be interested in the maximum value of this type of function, if you like, okay? In this case, they give you part one to just find. I'm not going to do the part one. You see, the part one is they ask you to find these numbers, y of 20, okay, y of 30, and the y of 60. This is the different numbers that you are going to have the result. If you grow, this is 20,000 plants, 30,000 plants, and 60,000 plants, and that's going to be the one. I'll give you the numbers if you like at the end, but the part that we are going to be interested in is going to be part B and C of this problem. So you're not going to see that part one. The part B is, you want to know how we're going to find your maximum. You see, they ask the determine. Okay, that's the part that we are going to be interested in. Determine the number of the plant, means the value of n, number of plants, okay, per okay, acre, that will maximize the result, that will maximize, okay, maximize the yield, if you like. And they ask you to run that to them. So this is the part that we're going to be interested in, okay? So we would like you to give us, for what value of the n, this function would be a maximum, okay? And then they ask for the maximum value. So what is going to be, okay? What is the maximum value, or in this case, what's going to be the maximum yield? So basically, the problem is, this is a quadratic function. You see, whatever it is, most of the models in the application are quadratic. This is a quadratic function, and we would like you to identify that for what value of n this function is a maximum, and what is the maximum value. Okay, so basically, if you want to translate the problem is, for what value of the variable of n, the function, if you like, or say the function yn is a maximum, okay, is a maximum, and that's going to be the case. And what is the maximum value of yn? So that's these type of problems, whatever it is, you drop all the neighborhood, if you like, and this is what we would like you to do for us. Okay, you know that the maximum or the minimum of a quadratic function would happen at the vertex. Okay, so what you are going to do is look at this function from that point of view. You know that your a is going to be equal to, okay, quadratic function. A is the coefficient of the n squared or x squared, which is a negative 0.103, and you need the b. B is going to be 8.32. You just need only these two numbers. Okay. Now, the important part that most of the people, they missed it is you have to confirm that you get a maximum. Okay, that's the important part. So you are going to tell us that this is it. You say that A equal to the negative 0.103 is negative. Remember, when A is negative, the graph is curving down. So you are going to have a maximum. Okay, so this is going to be the case. So, and you can say that the yn, or the function, has a max at what? Remember, at x equal to n equal to, in this case, n equal to negative b over 2a. That's it. But you have to give us these expressions, okay? I've given this type of problem several times in your course and pre-calculus course. Most of the people, they miss this one. You are going to be taking out some points because you have to prove. You know that this number can be a minimum or can be a maximum. How do you know that this is a maximum? So make sure that you prove it, then you substitute. It's easy to substitute.
What's it say after max?
Has a max at n equal to, vertex n equal to, okay, remember, negative b over 2a. Let me rewrite it. N equal to, that's n is x usually, okay? N equal to negative b over 2a at the vertex. Okay, now you have these two numbers. It's going to be negative. What is b? B is 8.32. Okay, 8.32, and the bottom one is 2a is going to be 2 times negative point, 103 if you like. Okay, and then, you know, just use, simplify it. This is going to be negative. The top would be 8.32. Okay, and the bottom one is going to be 602 point. Okay, it's a negative, negative would be positive. So n would be 8.32 divided by 0.206. Okay, this is a number of the whatever it is. It cannot be negative. Okay, so I just where is the calculator? I have the solution of this one in full, but I want to check the calculator to get it. It's going to be 8.32 divided by what is a 0.206. 206. Okay, I have something like 40.38. Remember, these are thousands. Okay, thousands plants, and it's going to be n equal to, okay, I have 40.6 is 1,000, so I go with the 388. Okay, because I can, I can multiply by 1,000 to get these numbers, or we can run that into the 40. It doesn't matter really. Okay, but this is going to be a kind of units, if you like. So you have to run that somehow. Okay, so I go with the 40 in this case. Okay, so that give me the number 40, and or you can stick with the decimals because this is thousands. But they give you the instruction. What was the instruction? Run that to the nearest 100 plants. Okay, to the nearest 100 plants. You can call it 40. Okay, so this is going to be n. Any question? And you know that you drop it into the function that give you the maximum value. So what is going to be the maximum? Okay, the maximum value of your function, and the function was y of n, is going to be y of 40. Then you have to substitute and get the result. Okay, this is the function. Okay, you have to use your calculator. to get this result. Okay, yn equal to the negative, okay, I write it down here. So it's going to be negative 0.103, okay, for the squared, and plus, okay, plus 8.32, okay, 8.32 times 40, okay, and the plus 15.1. Okay, you can use your calculator to get these numbers. Okay, so this is, you know, this is the way you are going to use these type of ideas. Okay, so it would be better to be patient and to get these numbers. Okay, I did have the but I leave it for you just to check it. I did have the numbers if I can find it. I gave this question on the test pre-calculus at the university, so I just wanted to see it. Okay, this is going to be the case. Yes, if you simplify it, so the result would be 183. Okay, so the result is going to be 183. So y of 40 is going to be equal to the 183 eventually. Okay, if you want to see all those numbers, I can show you the numbers that I have. Any question? So, you know, this is the, you know, the future, the application. So why not? I just want to show you the actual solution. Can you see it? The one over here.
Those answers to the test.
This is the answer of this number. The number 7. Okay, that was the one, you know, I gave them as a question. So that is going to be the result. I give you a similar one to you for you. I have a nice one for you. Okay, so this is if you want to get y equal to 20. Remember, y of n equal to 20, you just substitute. We are not going to give you this part. For your case, that was a pre-calculus, they can do that. You see y of 20 is 140. So this is when if you plant 20,000 plants, that's going to be the result. Y of 30 is 172. Okay, you get a bigger one. But when you go to the 60, you see the number would be dropped. You get 143. So this means you are going to get the maximum somewhere here. And we got it at 40. Remember, when n equal to the 40, we get the maximum, which makes sense. In case of 20, 140, 30, 172, if you continue, the number would be lower. So that is it, and this is the one that we did. Okay, so quadratic function a equal to, and this is the b. So as we talk about it, this is going to be a maximum. So the maximum is 40 that we got over here, and we drop the 40 in, that gives 183, which makes, you know, makes sense. So be prepared for it. You know, it's not going to be difficult, but there are decimal numbers, and you see, you get a nice result. But most of the people, they did it, those people, but they missed this part, you see. They didn't confirm it. You have to give us a confirmation that it's maximum. How do you know that you get, you know, how do you know that you get a maximum? So you have to confirm it for us, okay? So don't miss it. It's not a difficult, okay, a difficult problem. So this is going to be the case. Any question? So that give you, of course, you need a calculator. Yes, you need a calculator. Without calculator, you cannot do this. You're not. It's going to be a problem from everyday life. Lots of decimals. Yes, of course, you need a calculator for the test. you need the calculator to be able to operate. Okay, so pay attention to this type of problems. Nice. Okay, you do whatever, all these problems. So what? Okay, at the end of the day, you should be able to do this type of problem for us. Okay, so that will take us to the conclusion that we're going to have. The other problem, we did this for your practice one. Okay, so I go back and I give you the inverse function one. You did all right on the test, but a couple of you missed it. Okay, so we give you one inverse problem again. The only thing that is missing from here that you have to study from your quiz is composition of two functions. Okay, everything else is here. Composition of two functions. Remember, f of x, g of x would be given to you. Just take that one from your quiz. Otherwise, everything else is coming from here. Okay, let me just quickly remind you this inverse function. This is going to be number one, inverse, find the inverse. Easy question. Some of you missed that. Okay, the rational function one. Inverse of each function, otherwise you didn't have any difficulty. We repeat it again, and these are the candidates. The first one, easy, straightforward one, y equal to what? 5x minus 3. Okay, everybody did this one right. You know that the way we are going to do it, you have to solve for, okay, you solve for x. So that's it, 5x equal to the y plus 3. You divide by 5, x equal to the y plus 3 divided by 5. We accept it, or if you like, you can break it into the f-fifth of y plus 3/5. Okay, so this is going to be f inverse of y. F inverse of y is f-fifth of y plus 3/5. Okay, but if you would like to get the x as in your book, you can call it f inverse of x, which is f-fifth of x plus 3/5. Okay, this is my method. You know that in your book, they switch the x and the y first, and then they go for it. Okay, it's the same thing, but if you are in calculus and you do that one, I give you 0 right away. But anyway, it's college algebra, you can do whatever you like. So make sure you get it. I accept both of them as a conclusion. Okay, when both functions are appear at the same time, you cannot use x for both of them. That's the reason that I'm telling you. But anyway, we accept it. Okay, any question? So whatever you did on the quiz, you repeat it again to get your 10 points. This is the second part. Some of you feel uncomfortable about it. Okay, what was this one? Y equal to x plus 1 over x plus 2. You know that. You have to cross multiply to get the x. Okay, again, my method is solve for x. So this is y over 1 equal to x plus 1 over x plus 2. Okay, cross multiply. So that gives y times x plus 2 equal to the x plus 1. Okay, multiply it. It's xy plus 2y equal to the x plus 1. And remember, you want to solve for x, so you put the x's together and the y together. You want to find the x, so factor out the x. Y minus 1 equal to the 1 minus 2y. Okay? But you want to divide by the coefficient of the x. So x would be 1 minus 2y over y minus 1 with the condition that the y is not equal to 1. So this is f inverse of y. Is 1 minus 2y over 1 minus 1. If you want to write down it as is in your book, book. Now you change it to the x. So 1 minus 2x over x minus 1. Okay, just check your quiz. You know, some of you just missed that algebra. Otherwise, you did all right. Okay, that's type 2. Any question? The type 3 one is just an odd power a polynomial of the odd degree. Okay, that's fine. But if you get the even degree, then you'll be in trouble. So the part C, okay, the part C is y equal to the x to the fifth minus 1. If it's 3, 5, 7, that's fine. It's a 2, 4, 6, that's a red flag. Okay, you got to be careful. So this is easy. Solve for x. So that would be what? X to the fifth equal to the y plus 1. You have to take the fifth root. Okay, fifth root of x to the fifth root of y plus 1. So this fifth should disappear. Since it's odd, you don't need any absolute value. X equal to the fifth root of y plus 1. So f inverse of y is just the fifth root of y plus 1. You like x, so change it to the x. F inverse of x equal to the fifth root of x plus 1, and then you find. Any question? So that's very typical one that you have it in all over the places in your book. The red flag is when we get even power. Y equal to x squared plus 1. X squared, x to the fourth, x to the sixth. We in trouble. So what is the trouble? We solve for x. You know that it's going to be x squared equal to y minus 1. To find the x, we have to take the square root. The square root. But we know that square radical x squared would be absolute value of x. And that would be troubling because you know that you drop the absolute value, you pay for it. So that is not going to be the case. Remember, for the function, you must get only one solution, not two solutions. We cannot have a repeated factors, if you like. So in this case, you are going to tell us that the inverse function does not exist. Okay, the inverse of the function, okay, of the function does not exist. And then you're done. Okay, that's it. Put them nicely together. Make sure that one of those FOG, remember the composition of two functions. Added to this collection, that's it. 11 questions for the test. Okay, so study your quiz plus the one that I did tonight. 11 questions. Okay, that's it. Any question? So study this one. You see, most of you did very well on the test one. You get something nice on this one, then you can drop one of your tests. But it's nice to get all the tests, of course. Okay, but when you get, two nice points that give you better, better foundation, if you like, or the basis for the rest of the course. And then after your test, it's going to be quite interesting. The functions are going to be two exponential function and the log functions, many nice applications. So it's not going to be difficult. But these sections that we did are very rich, and they're not heavy really, but very useful part of your course. The other one would be easy. Okay, any question? So see you on Wednesday. You need 2 hours to do it. As usual, we do it on Zoom, and you be posted, and then now you download it back for us. Okay, any question? Study this one for the Wednesday. Have a good night and see you on Wednesday. Bye-bye.